The steps for solving radical equations containing square roots. Step 1. Isolate the radical on one side of the equation. We want to attempt to get the radical alone on one side. But I want to insert a statement here on number 1. And I want to make sure that you make a note of it. There's also a rule when solving radical equations that you cannot have more than one radical on a given side. You can't have two radicals on either the left side or the right side. You can't have any more than one radical on a given side. And we're going to see certain situations as to what we're going to have to do. But step number 1, isolate the radical on one side of the equation. Now when Kristen brings that camera right back over here, here's our first one that we're going to look at. We'll kind of do it step by step. The radical of x plus 2 is isolated. It is alone on the left-hand side. It doesn't have anything else on its side. So step number 1 has been honored. Step 2. Square both sides of the equation to eliminate the radical. So here we go. I'm going to kind of keep that right there, and I'm just going to bring it down again, just so I can keep that original equation intact. Now we're going to take this equation and honor step 2. We're going to square both sides. When we square the radical of x plus 2, we get the radicand. There's no major work that you do. We've already given you the rule. When you square a radical, you get the radicand. So we get x plus 2. And that's going to be equal to the square of 6. And now step 3. Combine like terms on each side of equation. We don't have any like terms to combine. Step 4, if the equation still contains a radical, repeat steps 1 through 3. We don't have to repeat steps 1 through 3. We no longer have a radical in this new equation after squaring both sides. So we just immediately go to step 5 and solve the equation. So negative 2 on the left and negative 2 on the right, and x is equal to 34. Now notice, I'm not saying that it is 34, because we've already shown to you when you square both sides of a radical equation, you might end up with an extraneous solution. Now, there's only one proposed solution here, 34. It's either going to be the solution or it isn't. So we check it. And I'm going to try to check it in here without showing a great deal of work, because I don't think we're going to need to show a great deal of work. If we take 34 and substitute that in place of x, I'm just going to kind of write it above it in red. People, 34 plus 2 is 36. The radical of 36, 6. It's good. It checks. And we're done. That's number 1. Okay. Now as we go down the lineup of equations, we'll notice that we're just going to add little information as we go. So let's go to number 2. The radical of w minus 3 plus 7 is equal to 11. Step 1. isolate the radical on one side of the equation. We want to get this radical alone. We got to get rid of this positive 7. The addition property of equality. Opposite on both. Subtract 7 from both. And we'll get it down to the radical of w minus 3 is equal to 4. So now we have the radical isolated on one side. Step 2. Square both sides of the equation. Tuck to the second. Tuck to the second. Left-hand side, when we square the radical of w minus 3, you get the radicand. And when you square 4, you're at 16. Now, there isn't any terms to combine. Solve the equation. Positive 3, w is equal to 19. Put it in the original. Now, very carefully. 19 minus 3, 16. Let me just kind of... The radical of 16 is 4. And 4 plus 7, bullseye. It checks, and it is honored. It's not extraneous. It is the solution. Number 3. T is equal to the radical of t squared plus 2t plus 3. Step 1, isolate the radical on one side. It's isolated. The radical is already alone on the right-hand side. Step 2, square both sides. Tuck left to the second. Tuck right to the second. When we square the left, t squared. When we square the right, we get that trinomial radicand. T squared plus 2t plus 3. Now, it appears to be quadratic upon glancing at it. We need to get it in standard form. We need to take this t squared because it only has one term on the left-hand side and get rid of it off of the left-hand side and move it over to the right so we can get it in standard. So the opposite of 1t squared is a negative 1t squared. So minus t squared on the left and minus t squared on the right. Draw the line. This becomes 0. The t squareds go. So when the t squareds cancel out, so does our quadratic equation. We'll get 2t plus 3. Move the 3 over to the left-hand side, because this is just a regular linear equation. And we'll have negative 3 is equal to 2t over 2 over 2. The proposed solution is t is equal to a negative 3 over 2. Now we're going to need to check it. So let me erase some of this material right here so I can show the check. We show it in the original equation. So let me just be safe and here's the original equation. So in place of t on the left-hand side, we'll put a negative 3 over 2. And that's supposed to be equal to, on the right-hand side, t squared, a negative 3 over 2 squared. Plus 2 times a negative 3 over 2. So I'm going to write 2 over 1 times a negative 3 over 2 plus 3. Now, folks, I'm going to share something with you because it can avoid some work, especially on this one. I'm going to take you back to the very beginning of chapter 9 when we were talking about this symbol. The literal meaning of that symbol is the positive square root of. That means anything that is underneath that radical sign, if the index is square root, then that radical sign stands for the positive square root. That means the answer to all of this has to be positive. And we'll notice on this left-hand side, when we go through all of this work, and it has to end up being a positive answer, this is saying that it's going to be equal to a negative. It can't. Now, that doesn't mean that I'm not going to continue on with this to point it out, because I will. But we're going to find out that this proposed solution of negative 3 over 2 is not going to work, because this stands for the positive square root of. And we're not getting a positive square root here. We're getting a negative. But we'll go ahead and do it. I'm going to bring down that negative 3 over 2 and that equal sign. Then I'm going to bring down that radical. And let's start simplifying this. A negative 3 over 2 to the second would be negative 3 over 2 times negative 3 over 2. A quick way to do that is we can take this numerator and use the negative sign for this numerator and go a negative 3 to the second power would be 9 over 2 to the second power would be 4. This is a positive times a negative, so that's going to be a negative. The 2's will cross cancel out. We're going to be left with a negative 3 and then plus 3. Well, this negative 3 and this positive 3 will cancel one another out, and you'll see the positive square root of 9 over 4 would be 3 over 2. And 3 over 2 does not equal negative 3 over 2. It doesn't check. So, t being equal to negative 3 over 2, it's extraneous. It doesn't count. So the solution that you write down, you don't leave it empty. You write down either no solution, or you can write down what I believe the textbook will show in the back of the book. They'll show the symbol for an empty set. It's a 0 with a diagonal line through it. Either one is good. No solution, empty set. That solution was extraneous. And it was extraneous from the get-go, because no positive square root can equal a negative. It's got to equal a positive. Now, if you're thinking about asking right now, if I see that on a homework problem or on an exam, can I avoid showing the check? Can I just simply write down that there's no solution? You go ahead and do that. That would be fine. Okay? Because that's exactly what it would be, assuming that there was only one proposed solution that that given radical equation had. Okay? Let's move it to number 4. Now, number 4 will move into kind of the next set of problems that you'll see. The radical of 7n plus 1 minus 4 times the radical of n minus 5 is equal to 0. Now, folks, because I'm going to need to have a little bit more room, I'm going to take down those steps because I don't think we're going to need them anymore. We've done a few of these. So let's take a look at number 4. We isolate the radical as best we can. And we realize that we can have no more than one radical on a given side. So one of those radical terms has to be moved. And I believe the easier one to move would be the one that is preceded by this negative sign. So if we want to eliminate this negative 4 root n minus 5 and move it over to the right-hand side, we're going to have to do the opposite. And so I'm going to show it. The opposite of a negative 4 root n minus 5 is positive 4 root n minus 5 on the left and positive 4 root n minus 5 on the right. Now let's kind of make it a bit cohesive here and put it together, and we'll have on the left the radical of 7n plus 1 is equal to, on the right, 4 multiplied by the root n minus 5. Now we don't have any more than one radical per side. So this is fine. Now we'll square both sides. We'll square the left. And we'll square the right. The left, I'm not bothered about at all, because when you square that radical, you get the radicand. But folks, pay careful attention and just remember you can pause when you're looking at this little part right here. When you square the right-hand side, there's two little factors that have to be taken to the second power. The 4 has to be squared, and then we have to square the radical of n minus 5. There's a key little word that I'm going to write right here. The use of parentheses is going to be key. It's a must. Let's square the 4 down. Now you see that 16 is going to have to be multiplied by the result of squaring m. So get a parenthesis ready. And now let's square the radical of n minus 5, and you're going to get n minus 5. So now we've got a pretty little equation. 7n plus 1 is equal to, distribute, 16n negative 80. It's linear. It's not quadratic. I believe I'm going to move the variable terms and get them over on the right-hand side and get the constant terms over to the left. Negative 7n equals negative 7n. If the variables now are on the right, then we're going to have to move the negative 80 over to the left. Opposite. Positive 81, positive 80, positive 80, positive 80. On the left, the 7n's go. 81. On the right, 16n coupled with a negative 7n, 9n. Over 9, over 9. Again, not the solution, but the proposed solution is 9. You see, I don't circle it yet. It's just a proposed solution. Now we're going to check it into this original equation. Not any of these. The original one. And I'm going to stick that 9, that n is 9, right here. And right here. Now let's just kind of do it carefully right up here. I think I can do it. Folks, 7 times 9 is 63. Plus 1, 64. The root of 64 is 8. Minus 4 times the solution we're going to get here. 9 minus 5 is 4. The root of 4 is 2. 8 minus 8, 0. Good looking answer. It stays. It's not extraneous. It is the solution. So that's number 4. Let's do one more and then we'll kind of stop this given video and because I want to make sure that I don't lose any of these. So let's just pick up number 5. And number 5, you're going to see something again, maybe a bit more of a challenge. But number 5, the radical of 3r minus 5 plus 3 is equal to r. Isolate the radical as best you can. Well, we can isolate it. We'll get rid of that positive 3. We'll go opposite on both. And now we have on the left the radical of 3r minus 5 is equal to, on the right, a binomial, r minus 3, or negative 3 plus r. I believe I would do the r first. Right? It's isolated. Square both sides. Here's the key. I'm not concerned about him. It's him. We have to square that binomial. So I'm going to show an added step right here because I want to be safe. I don't want somebody to square this binomial wrong by just going r and squaring negative 3. That is not correct. So I'm going to prevent an error. Let's square the left-hand side, and we get the radicand. On the right-hand side, I'm going to set this up as a FOIL arrangement. This base binomial is r minus 3. That's got to be taken to the second power. That means the binomial r minus 3 is going to be multiplied by another r minus 3, and I think that is a safe way to go. We don't want to lose this one. Bring the left down. Now we're going to FOIL. First terms. R to the 1 times r to the 1. R squared. Now I'm going to do the outer and the inner in one step and combine like terms. Outer, negative 3 times r. Inner, another negative 3r. Combine those. Be careful. It's negative. Those are two debts. And then the last, negative 3 times negative 3. So if you know, and you really know how to square a binomial correctly, you're going to get this. All right, now we can tell by looking at this equation, it's quadratic. That r squared is not going to go away. And he's already on the right-hand side. So because it's quadratic, and the only way that we have solved it at this point is by factoring, we're going to move each of these terms that are on the left-hand side over to the right. So very carefully, negative 3r on the left, and a negative 3r on the right. Positive 5 on the left. Positive 5 on the right. Got a 0 is equal to r squared, negative 9r, positive 14. Bring down the 0, bring down the equal. We factor the trinomial that's on the right-hand side. GCF, nada. 4 terms, no. Trinomial, yes. AC, we don't need it. It's 2 binomial factors. They each must begin with an R. The sign of the last term is positive. That means both binomial factors are going to be the same sign, and they're going to carry the sign of the middle. And because he's also positive, it means really add. Well, 2 factors of 14 that when really added together would give 9. Now the 0 factor property. R minus 7 is equal to 0, or R minus 2 is equal to 0. R potentially might be 7, or R potentially might be 2. But I'm circling nothing because we have to check. And we're going to check it into this original equation. Let me just kind of isolate it a bit. Here's the original. Let's try 7. Let's put a 7 here. And let's stick a 7 here. Folks, 3 times 7 is 21. 21 minus 5, 16. The root of 16 is 4. 4 plus 3, 7. He's good. He stays. Now let's do the other one. And check that one. And if I can remember what that was a 3R minus 5. Let's try 2. A 2 there. A 2 here. 3 times 2 is 6. 6 minus 5 is 1. The radical of 1 is 1. However, 1 plus 3 is 4. It's not 2. No good. He's extraneous. He's the only one that we can take. We'll stop it right there. There's going to be another part because there's other key ones that we need to look at. So you can wipe that perspiration maybe off of that forehead of yours or what, but keep a smile on your face because this is pretty straightforward stuff. You just got to slow down. We'll join you in a moment.